Hello everyone. Today we'll talk about initializer inheritance. We have talked about that a subclass will always inherit the properties and methods from the superclass. But what about the initializers? Are the initializers always inherited from the superclass? The answer is the initializers can be inherited, but not always. The inheritance can happen only if certain rules are satisfied. First of all, the subclass must provide default values for the properties it introduced. And on top of that, there are two rules. Rule number one is for designated initializer. If your subclass doesn't define any designated initializer, it automatically inherits all of its superclass's designated initializers. And rule number two is for convenience initializer. If your subclass provides an implementation of all its superclasses' designated initializer, either by inheriting them as per rule 1 or by providing a custom implementation as part of its definition, then it automatically inherits all of its superclasses' convenience initializers. Now let's look at an example. We have a class vehicle and it has a designated initializer and a convenience initializer. And then we have a class bike, which is inherited from vehicle, and bike has a property age, which is a new property that it has introduced, and we have provided a default value for it. So this is the precondition for the initializer inheritance to happen. And since bike didn't define any designated initializer, the rule number one is satisfied. So bike will inherit all the designated initializer from its superclass. So this one is inherited. And that's why you can create B1 by calling the inherited initializer. And because bike has inherited all the superclasses designated initializer, the rule number two is also satisfied. So the vehicle's convenience initializer is also inherited by bike, and that's why you can create B2 like this. Now let's make some changes to the bike. Say we define a designated initializer for the bike. Init super.init type bike. So now bike has its own designated initializer, and the rule number one is broken. So bike will not inherit any designated initializer from vehicle. That's why this code cannot compile. And because bike doesn't provide an implementation of the designated initializer from the superclass, the rule number two is also broken. So the convenient initializer is also not being inherited, and this code also cannot compile. Now let's define another initializer. Override init type string super.init type. Now the bike has provided its own implementation of the superclass's designated initializer. So the rule number two is satisfied, and the superclass's convenient initializer is inherited by bike. Now let's talk about required initializer. If a class has a required initializer, all its subclass must provide implementation of that initializer, either by inheriting it or by providing a custom implementation for it. So here we have a parent class and it has a required initializer. Then all of its subclass must provide an implementation for this initializer. Then we have a child class which is derived from parent class. And as we talked about before, if the child class doesn't provide any designated initializer by itself, it will inherit all the initializers from its parent class. So this initializer is inherited by the child class. So the requirement is satisfied. However, if we provide a custom initializer for the child class, init age int super.init name Bob. Now the child has its own designated initializer, and this initializer will not be inherited by the child class, and this requirement will not be satisfied. That's why we have a compilation error. So in this case, in order to satisfy the requirement, we have to provide a custom implementation of this initializer for the child class. So required init name string super.init name. Now again, the requirement is satisfied and this code can run OK. Now we have a grandchild class which is derived from child class, and since child class has a required initializer, the grandchild must provide its own version of the implementation for that initializer. Otherwise, this code will not compile. One thing to note is that if the child class doesn't provide any initializer, then it will inherit the parent class's initializer. But the inherited initializer is not a required initializer of the child class. In other words, the grandchild class doesn't have the obligation to implement the required initializer from its grandparent class. That is why this code still compiles. Lastly, let's talk about initialization with closure. When you define a property for a class, you can provide an initialization value for that property. But sometimes this value must be computed. For example, we have a creating time property, which is to record the time that this object is created. And this value must be computed. For that, we can use the initialization with closure. So this closure is to compute the value and then initialize the property with that value. This is different from a computed property. A computed property's value is computed every time that property is accessed. But for the initialization with closure, the computation only happens at the time when the object is created. So it only happens once per object. Also note that there are a pair of parentheses at the end. If you forget about these parentheses, you'll end up assigning the closure itself to the property, which may not be what you want. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.